Hope this is visible.
If you can increase it, yes, that would be nice.
Awesome. Okay, so just to give an introduction, so for today's technical discussion, the main topic is all the issues that are being planned and what the DMS should look like with the new design and the new architecture. So basically just something like a disclaimer beforehand. So this is not an exhaustive list of issues. What we're going to be talking about, at least for my part, is going to be the bigger picture, and then some issues that we can get started with. So obviously there are going to be additional issues that are needed, and existing issues might need to be redefined or explained better in the as we go. Yeah, if you have any questions, we can do it at the end or interrupt you at some point. So to start with, the actor interface is one of the priorities. This is because nodes and allocations are supposed to be actors, and within this new DMS that we intend to have, basically each DMS, as soon as it's onboarded and as soon as it has a networking with other DMSs, it becomes a node. So think of it like a program and a process type of difference between nodes and DMSs. So these nodes that do communicate with other DMSs or other nodes would be the ones making the decision to create to send jobs, to receive job specs, to actually run those jobs through allocations, because actors can create other actors, and in our case, nodes would be creating allocations. So we have one issue that Mobbing got started with yesterday, so it needs a little bit more definition, but we have here actor module as an issue. So please go take a look at that, and then if you have suggestions, additions, things that could be corrected, anyone can suggest it. So this is going to be the first one, but it doesn't mean it's going to be the final one. So here is another one that's an important aspect of the actor interface, which is remote procedure calls. So let's say, imagine every actor implements a get state function, and then through their messaging, it should be possible for actors to do remote procedure call on other actors. So for example, let's say to get their state, to get some health check. So it's defined at the bottom to get some health check. Yeah, these kinds of things. So this will also be an issue. Have you created it here? Implement remote procedure call for between actors. Moving to the orchestrator. So this is another module that's going to be, when I say module, I don't mean Go modules. Another module that's going to be very important. So with orchestrations. So I'm sure you all have seen the blog posts that detailed orchestration mechanisms. So these things are defined out of those posts, and then subsequent discussions that happened after that. So the main thing is, the first one here is the capability model. So this will describe what a DMS or a node would be capable of doing. So let's say amount of resource available, like whether there is a GPU or not, what type of GPU, what model, etc. We can also include bandwidths, any capability basically that any node is able to offer within the network. This capability model also comes in from the other direction, which is it also serves as a requirement for jobs, because when someone is writing a job spec, then they're basically writing a capability requirement essentially. So this involves the comparison as well. So let's say if I have 4 GB of RAM, but then some job spec is written saying at least 3 GB, then my machine satisfies. But let's say if there is another machine that has 3 GB exactly, then that is a better fit again. So yeah, we're going to have to compare between the requirements for capability that the job spec has and the capability that a machine has. And that's going to be the main concept here in orchestration. So let me just skip over this cancelled ones. Kabir, if there is more explanation needed, please interrupt me. Yeah, so let me skip over this one. So logic to compare bids and choose the best. So this one is this one involves the capability model as well, but other than that, it also involves the user's choice to bid or not on a certain request for bid. So imagine one node publish a job spec saying, okay, who can do this job for me? And the highest I'm willing to pay is this much or something. So other compute providers should be able to bid on that job spec saying, I can do it for 3 NTX, I can do it for 4. And then at the end, the service provider should be able to decide which machine or which node or which compute provider takes that job. So the capability is involved in there, but additional to that, the user choice for taking on a bid would also be considered, because the user should be allowed through some configuration to specify. So for example, let's say if it's a personal machine, let's say if it's a laptop, and if I'm not using it at night, I can say that, okay, if it's during the night, maybe when electricity is cheaper, etc., take jobs for for 1 NTX per minute. But if it's during peak hours, I can say maybe it should be 2 NTX per minute, etc. The minimum I'm willing to work on for. So yeah, that's what bid involves, in addition to comparing the capability, because before getting to the price, the compute provider has also needs also to compare whether it has the enough amount of resource or not. Okay, so the next one is implement logic to handle sending and receiving job invocation requests. So this is a bit related as well. So it's within this logic, but this is the specific protocol that's needed to send a job request or a job spec, and then for the receiver compute provider to handle it. So how it's going to handle it, what the protocol is going to be to send this job invocation request. This is what this one deals with. So this is also one thing we have to do. Logic to handle events behaviors after receiving a job invocation. So this is related to what I just mentioned.
So
okay.
just one comment.
Yeah.
What you mentioned in the beginning is this remote procedure call logic. So these things should go through remote procedure call logic, which means it will a message saying, please run this job. And that is basically they will use the same interface. We still will have to build the messages so that actually actors will understand how to deal with those messages, what kind of behaviors they have to invoke based on those messages, but the general interface will be actor interface of remote procedure calls.
Yeah. Thanks. Okay, so coming here, it's basically the same one explained above with the bid here. So yeah, it's basically how a bid request can be handled, and basically when it's also sent as well. So it's the same concept as this one. Orchestrator graph node. So this is still in design as indicated here, but the main thing now is for us to think about it. So at least the way I understand it is, imagine we have the low-level network. So network package deals with peers at a lower level. So it's doing hole punching, it's like communicating addresses, it's helping other peers be able to tell what type of NUT they have, etc. And it builds basically the network package. For example, if we're using a DHT, it builds its own graph of its view of the network. Just a little bit above that, we filter peers, let's say, based on, just this is an example. Let's say we filter peers based on latency, we filter peers based on some closeness parameter, or maybe based on a private IP or a private swarm, some criteria that we will have. And above that, we have application level requirements. So at the same level as DMS. So how much resource does this other node have, and what job is it running at the moment? So these are going to be high level needs, right? So these things need to be able to be represented as a graph at the node level. So that like one node or one DMS needs to have a view of the network that looks at it from the perspective of, okay, what resource does this other node provide? What job is running on this one? How can I find a machine that has the capability that I need, etc. So this is going to be a module by itself. So when I say a module, what I mean is it's going to be an interface by itself, or some package or sub-package by itself, which will have a view of the network as a whole. So it doesn't matter, let's say, if it's connected. So for example, it doesn't matter if machines A and B are connected at the lowest level, whether they have dialed each other and are maintaining a connection between each other. It shouldn't matter on the graph. Even if we don't have a connection, then the node will want to have a view of the network in general. So that's something to think about, at least at this moment. Implement orchestrator those graphs a package. So yeah, this is related. When we move to jobs, some work has already been started by Dawit. So the main thing that's currently being done is deciding the format of the spec, the job specification. So think Docker Compose, think HCL for actually think Nomad job specifications, think Kubernetes job specifications. So similar to that, we should have a job specification format that's able to tell a node how many other nodes to use to deploy a job, what constraints to apply on the resource that's going to be allocated for those jobs, what else checks to run, etc. So everything that deals with the job should be specified on the spec, and we have to decide on the format. So that's what mainly this issue here is. Implement parser. So that's what Dawit is doing. Compare spec with capability. So this is not yet started with comparing capability with the requirement capability. So like the present capability, or yeah.
I would say it is started because unfortunately it is related to this capability model. So basically, yes, it is started.
Okay.
Well, fortunately or unfortunately, but yeah. So
okay.
I think when I will have a kind of more or less clear picture, I think that will probably warrant a technical discussion just around the capability comparison capability model and stuff, because it also will involve not only comparison between machine and job request, also between bits and between bits, for example.
Yeah. Okay.
So I'm kind of trying to figure out general comparison of general structures, which is a little bit too general to even think about. So we'll see how that works.
Yeah. Yeah. All right. So yeah, a specification and capability comparison. So I think details will be going on this issue, if I'm not mistaken, Kabir. So yeah, if there are any suggestions, anyone who has an idea, like this is the place. Keep another responsibility that the jobs logic or like the jobs package has is keeping a registry of locally running allocation/executor. So it should be responsible for managing locally running workload. So that's another task he needs to be doing. When we come to Node, I explained it earlier. So we have
actually, I had a quick question, maybe.
Yeah, please go on.
So regarding this comparison, comparing, let's say, it's not very well clear for me. So let's say these bits, we have these bits and we want to pick the best one based on some certain criteria. Is it part of job or it should be part of this matching? I don't know how we should call it, but
so actually that's a good point that you said, because what I started, I created a new sub package in orchestrator package, we still called matching, where I'm kind of putting all this logic because yeah, that's kind of orchestrator.
Nice. So it should not be related to job.
Well, I mean, the thing is that when we will define a job, we will define what is required capability to run that job. And the whole point is to use the same type to describe machine capabilities and job capabilities, because only then we can match them and we can compare which one is bigger and smaller. The kind of a nice thing is that, for example, how do you say whether GPU is good enough, or whether, it's easy for memory, for example, but then when we have, let's say, executor types, which are just string descriptions or enums for us, we have to define the comparison logic between executors. Okay, do you have this executor? Fine. But if you can run 3 executors, what does that mean? So there is certain custom comparison that we have to build in, which is the comparator. So yeah, that's what I'm defining and trying to kind of build the structures in, which means, yeah, we have to, and then prices and time considerations also come into place, which means preferences of bidders, whether I prefer price over time or time over price. That will define which bid I will take. So yeah, but the types are actually used by the whole package. But job will use capability type for the required capabilities. Machines will use capability type to declare the capabilities that they have. The allocations will use the same capability type in order to figure out what is available allocation when machines will run a bunch of stuff, but they have available allocation, which means we'll have to define also subtractions and additions of capabilities so that we can track total capability and available capability based on what is already running. So it most probably will span a bunch of stuff, and so the logic should be, so I'm kind of trying to figure out where to put that. A lot of things will go to models because the types will for all the packages. And yeah, so I guess I will try to define the logic, and then I will ask for help from somebody.
All right.
Yeah.
Sorry about that, everyone. Network got disconnected. Let me continue to just finish quickly. So node functions and implementation. So this is what was discussed earlier. That basically the node becomes a node, like the MS becomes a node as soon as it's onboarded, and as soon as it has networking and ability to communicate with other nodes. So yeah, this is the issue for that implementation. So the first thing we will need to do, at least with this node, is to define what it will need to work by itself. So for example, it would be networking functionality from the jobs package, functionality from the orchestrator package, ability to apply for a bid and also publish a bid, etc. Yeah, so this is going to be what we deal with on this issue. When it comes to allocations, functions implementation, so this is already started by Gustavo. So allocations are going to be basically the so just start with the name, and it would mean some resource allocated for some job, right? So there will basically be, so for example, let's say if you have a 4 GB memory that you onboarded for your node, and if there is some job that's running that needs 1 GB of memory, then the allocation would basically take 1 GB of memory from the amount of that you have onboarded, and then run an executor that makes use of that 1 GB of memory. So allocations will be hosting executors, and then allocations will be managed.
Actually, I had a question regarding that RPC call that we are planning to implement. As we know that one actor cannot force other actor to do anything, right? It can only make a request via message, and then other actor will act. So how will this RPC
Yes, so it could be that this RPC is not a good name, but I kind of didn't come up with a better one. Because you're right, one actor cannot instruct another actor to do something. It can only ask, and the decision of to do it or not to do it is another actor's business. However, so this is like request, please do this and this and that. However, even if I kind of do it this way, which means one actor cannot access directly another actor's state or influence, etc., or costs things. But then when let's say I'm asking somebody to do something, that somebody does that something, when the whole, let's say, sequence of events actually happened, how do I describe it? Who called them? Well, probably the message that somebody decided, yes, I can, the decision is mine when I'm getting a letter whether to respond or not. But when I respond to it, basically I responded because I received the message. So it's a little bit maybe subtle, but it doesn't break the model. And it also allows us to actually do the events which cause each other. However, in order to make this, so the RPC basically model what will, so for example, job invocation will be sent via this RPC model as a message. However, when I will get the invocation request, I have to be able to sort of, if I decide to kind of honor it. However, if I don't decide to honor it, it will be a problem because the contract will be signed before that between the two actors. So if I decide to honor it, I have to have tools to deploy it, which is the functionality which Dagim was explaining in the allocation, I believe, or jobs package.
Does that mean that once we have agreed on doing something, then the other actor has that capability to, for lack of a better word, instruct a certain functionality to be
well,
executed?
so the invocation itself, by the way, I see Tanya and Sophia here, so that's where contract comes in, because invocation says I'm sending a message to an actor and I'm sending a job request, which is okay, please deploy this and this and job and start running it. And also the invocation also has a contract and a proof of contract that, we already signed a contract and you promised to do this. But, we're not going to put anybody to jail if they don't do this. So invocation is, well, contract signed, please do this, what's signed. But so it's almost instruction. But it's not direct, it's still through the actor, through the messaging interface.
Okay. Thanks.
Yeah, sorry about that again, everyone. I'll try to do it as quickly as possible. Okay, so location was just explained, right? So yeah, it's basically should represent some allocated resource and some workload that's running on that allocated resource. So general database functionality. So these are a few polishing things that we need to do for the to make it better. There are two that stand out, but one is to improve resource amount. So for example, the way we are checking for the presence of GPUs, how much memory and CPU that the user is allocating, how we're going to lock a certain amount of resource down, etc. So also, for example, let's say dealing with different platforms as well. Let's say regular cores and with the new CPUs that have like a efficiency cores. So these things need to be better modeled and implemented. Duplicate log bin, this is just depreciation, so I don't think it needs a lot of explanation. So with telemetry, so this implementation of default logger is for every package to basically log itself. So a logger implementation should be pluggable to each package, but unless that exists, they should have a default logger. So we currently are using the ZAP logger, which is a good logger, but on this issue, if anyone has an argument for switching to another logger, let's say log or zero log or whatever one, then that's some discussion I think that can be had. Yeah, as long as there is like some benefit to it, essentially. But ZAP is what's currently applied. So we can also have a database logs going to a database, logs going to an open telemetry collector. And final one here, chemistry instrumentation. So, so for example, let's say for the already existing code that doesn't have any instrumentation or any logging, that's one thing to do as well. And every new package that we're developing, we should add while developing it. But it would be a separate issue when it is an older code that already exists, but isn't correctly instrumented. So executor, there isn't a lot to do here. It's mainly done. Supervision functionality. So so let me talk about these 3 modules from this, and the rest I think you can get from the blog post here, just to make it a short description. So heartbeats and health check, we're separating them here because heartbeat should be voluntary. So let's say if I have A and B, and A is supposed to monitor B's health, then the heartbeat would be B sending heartbeat voluntarily to A. So it can be, let's say, it's just a heartbeat. So it says I'm alive. So imagine if it's an allocation. So an allocation can say I'm alive to the orchestrator, or like to the node orchestrator that deployed it, that created it. But then that same allocation should be doing health check with on the executor or on the actual application or on the actual job that it is running. So just to make this clear, I will show an example from the issue of specific health check, but the other one is health check implementation for actors. This is basically between actors. So actors checking another actor's health status. Just to show the app specific one, this is very much similar to how console does it. So imagine a job spec. So this is from the example that David created on his job spec parser issue. You can describe a task and an engine. So saying, let's say it's Docker, it should use the Alpine image. This is the command to execute as soon as you create the container. And then you should be able to specify a health check and say, okay, the type is command. And I want you to execute this command with this argument, and you should expect a Boolean true response every time you execute it, and please execute it every 10 seconds. So if the service provider specifies this type of health check, then this would be specific to that application that's running, and then it would be basically the allocation that runs it against the executor. So imagine if the executor is a Docker container, then we'll be running Docker exec health checker soak this. Imagine if it is, let's say, an HTTP type health check. That means you have to call a certain endpoint, so the user can specify that endpoint and specify the response to expect, whether it's healthy or not, and letting us know that to execute it in every 10-second interval. So this would mean that would either run it, so instead of localhost, for example, it can be the IP address of the container, or if the container is forwarding a port for health check, then it would be localhost 8080. So yeah, that's basically what health check and
so I would like to comment.
Yeah.
So you may ask, what is the difference between 932, 933, and 934? And the difference is that 932 and 933 will go through the RPC interface, which means this health check and heartbeats will be just messages between actors. However, 934 will be a different interface because that will be allocation executor relations. Executor is not an actor. We cannot use interface for that. So it will be something that Dagim was showing.
Yes. Thanks. Okay, so going to tokenomics, Kaveh, I think you can do this one, or let me know if this is necessary to cover now. But yeah, abstract design is needed for the most part.
Yeah, I can do it. So now the design of abstract tokenomics interface is pretty much approaching the fruition with some kind of, there is a merge request opened and being worked. So, and then based on that, we will implement interface which is needed for DMS like this. interface implementation, which is needed now for DNS. And that will need pricing logic, because pricing logic will go to the contract and will go to the bid comparison of bids, etc. and so forth. Therefore, it's pretty much inside the DMS kind of core DMS functionality which we are doing now. And then all the other interfaces will be implemented as interfaces for the further milestones to kind of implement the functionality. So I guess that would be the.
Thank you.
Yeah.
All right. So for storage, this is mainly about allowing access to remote storage. So for example, let's say with the current implementation, I think we have for S3, but the goal is also to allow, let's say, IPFS or other DMS hosting some data on Google Cloud Storage, whatever type of storage it may be essentially. So the current way that this is working is we get access to a remote data, download it, make it into a volume, and then allow executors to have access to that volume. So for example, let's say if there is some process that needs access to some data in some S3, and it's running on my machine as a computer, because my machine is a computer provider, then yeah, the storage package would basically handle fetching that data and making it available to the executor or to the container. So this storage package in the future should also need to deal with external databases. So let's say some Postgre database that's hosted somewhere else. So for example, let's say routing external database access through the peer-to-peer network would be one thing that should be supported with this storage package. But yeah, this is not for now, at least.
So just a commentary. It's almost like telemetry. What needs to be done is the abstract interface implementation, and then S3 is enough for now. But then we should be able to use this interface to build other databases, external data sources, etc., storage in the future milestones.
Yeah. Okay, so from test management, so mainly for Gabriel Abhishek and Sam, we need to target a unit test coverage of 80 to 90%, but this isn't for Gabriel Abhishek and Sam. This is for developers. So everyone in the core platform team, every time some new code that implements some new functionality is done, unit tests should be written for it. So this applies to all new incoming code without any exception. And when there is time and let's say no other priority task to do, then we should also cover existing code that is not tested well with new tests. So we should be targeting 80 to 90% release coverage at least. Another one, feature environment running and reporting test results to GitHub test. So I think this is done. Integrate TMS built into the CI/CD pipeline, build all test factor from HTML reports. So this is just to show that there should be detailed reports from the tests that run basically from the test suite. So currently, if anyone hasn't seen it yet, if you click on the coverage banner, you can get access to this coverage HTML. So if you are interested in writing tests, you can just come here and then take a look at the coverage to see which code you want to write a test to. So you can start from the least covered and then especially the least covered and most critical, and then work our way to the rest of the repository. Okay, so documentation. So
I would like to comment regarding this. So basically, what Gabriel, Abhishek, and Sam to some extent are doing is providing information for developers about all those things. So, for example, the first unit coverage. So on each merge request, we will have a coverage reports related to that. Let's say all the. So that is basically issue for test management, to provide all the information for developers to see what is the situation with coverage and with all the let's say, tests and so forth, so that they can kind of make an immediate decision what needs to be still updated.
Kevin, I think, thank you. Since you can only add yourself, Mobin sent a message on the chat saying, please add me to the storage module. Just so that it's not forgotten. Yeah, so for the documentation, we have covered, but yeah, also everyone else, especially working on a code, should be doing documentation. All packages should be accompanied with a README that documents how that package works, how the code inside that package functions, so that it's easier for, let's say, open source contributors or anyone else getting started with the team to have a clear understanding. So with network, so this is what Mobin was working on past couple of weeks, and it's ready for review. So that's basically the general network package that abstracts the LP2P and makes it available to the rest of the application. So on top of that, we need a private IP functionality so that nodes are able to form an IP, like a private IP network between them. So think VPN, but not VPN that's yeah, like how we regularly use it. Think VPN, let's say, for an office, right? You can have a virtual private network for a few machines, and then any traffic within that is encrypted, etc. And outside outside access is not allowed. So that's the private IP. So with private swarm, it's essentially similar functionality wise, but the difference is that we're not focused on having an IP network. It's just, let's say, with LP2P, we can have a private cluster of machines, that communicate only with each other, and other machines outside that swarm are not able to, have access or be able to communicate with those machines. So the first one is mainly intended for applications that, let's say, such as the Kubernetes use case, because there are, let's say, millions of applications that are able to work with IPv4 networks, but very handful that work with the LP2P network, right? So in order to support other applications that already work with IPv4 networks, one use case. So that's basically one use case to support IP networking on top of the LP2P networking. So checking return topology. So this is an issue. I'm creating an issue for this one. This is basically means we have to detect the type of NAT that machine is behind. So for example, let's say my machine can be behind a symmetric NAT, which is a very restrictive NAT that maps IP and port, so that hole punching isn't possible to establish a peer network. So on the DMS, it's best if we have an API for that. So let's say, so that the node itself can check itself what type of NAT it is behind, and make decisions based on that. And also a REST API, let's say, for other applications to check what type of NAT this DMS is behind, and a command line interface for the user to know. So essentially, we need to let the user know, or make it possible that to know what type of NAT that DMS is behind. So
basically that is part of capability. It becomes part of capability of node, whether it's behind this and this and that, because and also, for example, if it's somehow has static IP, it's a capability which is important for us to know, because sometimes we will need to know that a node has static IP in order to deploy certain things.
Also, like open ports and stuff like that.
Yeah, and that is with open ports, it's even more interesting because it can be closed, but a node may say I can open them. So how do you define that? But yes,
good question.
So I mean, in terms of, let's say, when we were talking, when we were talking about graph, this topology, whatever graph interface, is that at a certain point, let's say when we will start thinking anyway, it's even will be more kind of complex in the sense that capability of deploying certain jobs when those jobs will run on two nodes will be related on the speed of connection between two nodes, which doesn't really belong to any of them. It belongs, yeah, it's like artifacts of both. So, and this is why we will need the kind of graph, some kind of graph structures in order to reason on top of that, but they will be also related to capabilities of each node, which are within the graph. That's it. I'm finishing. I'm done brainstorming. So if Dagim, if you finished, maybe we can.
Yeah. Sorry for taking this much time, but if there are any questions, especially, yeah, but the issues where your names are mentioned, or yeah, any question about how everything is supposed to work.
I have a general question now that we have more, let's say, granular understanding of different things across the packages. Is how do we, I mean, how can one understand the functionality which is there that we want to embed within different packages? So like for executor it's clear, but then what will DMS package do, what will so that can be documented in the readmes that I'm working on.
Is it related to the DMS, like changes in DMS, or in general?
DMS, yes, but otherwise as well, like if we have now more stuff, right? Like supervisory, the blog that you wrote, and so where does that go? That functionality sits where, and is it like a separate package or sub package or whatever? So
No, so more the kind of how to say it in so functionalities. Most of those functionalities they span a bunch of packages. Like orchestrator functionality, it goes across network, well, less network, but jobs. Okay, there is a package, it has its own package. So it also relates to supervision function. So yeah, we have some changes in the package structure, which I think maybe Dagim could explain better. But in terms of documentation, and that is kind of documentation part, is that we have packages which are implementation of certain, let's say, functions. And the functionality, platform functionality, and we will explain them the way we have them in readmes. But the higher, let's say, application level functionality, which will be functionality of platform itself, will be explained in yellow paper, which is not finished. I mean, that is a part of yellow paper which is not yet done. So it will kind of explain those high-level functionalities and relate to packages. So I don't think anything in README structure will change, except as related to all those changes in the structure of the DMS repository itself, which Dagim may explain.
That's okay. I mean, if more expansion is needed, but
I mean, are we changing the structure of DMS from what it is now? I think that was also discussed on this issue. Is that also final?
so what do you mean structure?
Yeah, structure in a sense that something that we discussed again regarding moving orchestrator package under DMS and other packages under DMS, something that you did.
Yeah, by the way, those things, sorry, just wanted to say something about that. So these things are not only like design decisions, because they're also code decisions. So let's say if I have code in some package that I need to import from another package, and I see that the arrangement doesn't make sense, then a case can be made, like by the developer, saying, okay, this arrangement can be improved in this way. So this moving orchestrator to DMS, moving nodes to DMS, these things but I don't think they're going to be written in stone. Like if there is some enough case for them, then it's possible for them to be moved in the future. So for example, let's say when packages grow, especially in Go projects, if they grow and become more generic, then at some point you have to move it to inside to top level PKG package so that other packages can import it, etc. Yeah, things like this. So yes, like some structure would change, but it might again change if there is some reason for it in the future. But at least for the moment, this is what's going to make sense. But yeah, like argument can be made to move around things.
Understood. But it's fine if we change things in the future, depending on what we see is better for implementation. But
Of course, yes.
to begin
Yeah.
with, right now, since we're trying to come to a place where documentation is more or less mapping what the current state of things, what should be taken as a starting point, which can change, of course, as we move ahead. But at least to begin with, what is the reference that we should take? Is it the current structure on develop, or are we immediately changing?
Yes. Like current structure for develop was updated yesterday with jobs. Oh shit, orchestrator.
Yeah, it's actually you just
Oh.
the README file
Orchestrator?
left in the orchestrator. Yeah.
Oh,
So
yeah,
that's the
sorry
only
about
thing.
that. I will correct this. I will rectify this today. Sorry about this. Yeah, we'll definitely correct it just after this meeting. But yeah, with orchestrator moved into DMS, the structure should be what we begin with. Yeah.
And
All right.
actually, I can explain the logic maybe because I find it nice. Because the logic is that we put everything under DMS that cannot be run without DMS, but we have packages which can be used either by us as DMS or by other, let's say, project as a separate packages. At least this is what was the Dagim's kind of conceptualization of the structure.
Understood. So when it comes to DMS, if you have to describe the functionality, what is it? It will encapsulate now. The DMS package, I mean, not the DMS component, which will come in the yellow paper as Kabir mentioned.
So, Dagim, if you put press on DMS, you will see all the stuff there. Yeah, so it will have jobs, node, onboarding, orchestrator, resources. Node is the new package. The only new package is node. Now, I think Dagim is also thinking of actor package, but I'm not sure. Module.
Yes, actor might grow to be a package, but at least at the moment, maybe just a file as actor.go inside here would be enough. But if it grows, obviously, yes, it can. Yeah, it can be moved into a package. Like I haven't created it because at least my assumption at the moment is that a single file would be enough. But in the future, obviously,
I think so.
Yeah, there is a chance.
Okay.
Any other questions? Like since we only have 4 minutes left. Anyone like David, Santosh, especially from what you're working on, if you have any questions. Because Hamza's movements, they've been discussed, I think, in detail. So David and Santosh, if you have questions, especially David, since Santosh, you had a question about orchestrator, I think this week.
Yeah, actually, I don't have that much questions actually. I mean, me and Gustavo tried to discuss in more detail on the spec, and yeah, I put all my thoughts on the comments.
Awesome. Okay.
If anyone does have any question,
Thanks, Gustavo.
Can you hear me?
Yes, yes.
So my question was like capability model and all are like yet to be updated, or are they final at this point?
So that would be a question actually for the whole team. I'm thinking because I'm kind of doing it on the feature branch, And I also figured that some people are working on other feature branch which are related, let's say, with type definition, so on and so forth. How do we exactly collaborate on feature branches so that, for example, I can see it's feature branch, but we usually don't know who is working on what. It's not yet
my approach was just to leave room to just consider the capability is not done yet and just assign a placeholder for it and come back to it once it's done.
Yeah. So okay. What I mean, what do you need for that?
Nothing. Yeah, that would be just. So what we are trying, I mean, as far, at least me and Gustavo are trying to do is just to define a very basic capability definition and just go with it because it's not going to be the whole thing. It's not going to affect at least the whole thing. So we're just working on that. And once we're done,
in this sense, either I can. So that's the thing, that because I'm also defining this capability model. So the best would be that we are actually working on the same one. And I saw that there was let's say execution resources defined by you somewhere in jobs package. I don't even remember, executor package probably.
Yeah.
And I'm kind of using those ones and trying to align with this one so that I don't break anything. So yeah, I can basically, there is a draft merge request actually, having all those changes. I mean, it's things that I'm working on, but so this is my question maybe for Doug, Janina, and everybody. How can we share all this information so that even without merging, I mean, especially this big merge request, we can sort of still know who's doing what and to align. Otherwise, at the time of merge, we need to do all kind of adjustments just because we are working on the same stuff, all of us.
Yeah. I mean, if there is already a draft merge request, all of us can review it and see if the current implementation is going to work for all of us and have comments on there, maybe.
And we can see this interaction during the daily meeting. Actually, Gustavo was working on his issue and he need a job specification, and I asked him to talk to Dawit, and they are collaborating on that. I think one way to start seeing the need for this collaboration is during the critical chain daily meeting.
So actually, sorry, Abby, I will just jump in regarding that. So maybe we can include all those things that people are working on into the status update.
Okay, I will analyze that.
Okay, thanks.
Afi, would you like to go?
Yeah, Duggan, could you please open the executor module once?
Okay.
So actually, currently I'm working on a feature branch based on the executor. So
Yes.
there are some refactoring we done on the different types of GPUs. So I'm working on 466. Yeah, 466.
By the way, I saw the diff of this branch. I think you have a merge request.
Yeah, it's in draft currently.
I think
working on it.
Talk about it separately.
Yeah. So actually, I was
I've seen this one.
Yeah. So actually, there are I think some parts are beyond the scope currently because it's still undergoing refactoring. So I'm thinking that I have added some the functionalities that we had in the previous version. I have brought them back, but I think I need your the review from the team, also feedback from the team because it is related to other modules also. But my primary question is, we are planning to do everything through the resource.go. I think the GPU management, whatever we want to do we plan to do it through this resource.go module?
Actually, there's already a resource subpackage under DMS, and that's where most of the resource probe is happening. That's why I wanted to talk to you about this MR, because it's doing things like some of the things that already exist and other things that are different from the intention for, let's say, the executor package. But yeah, let's talk about this when we have time. And yeah, if also David can give comments like when you get a chance, please. And mail alerts.
Yeah, and well, yeah.
He
So
posted.
actually I added a diff description also as comment on the merge request, so it will be easy for everyone to understand what is going on here. So and
Yes.
and, yeah, and one more question I had is that we discussed one issue about using CLI based commands in Go, and like trying to avoid them when we are trying to fetch information from devices. So I was reading about it, and I saw that there are some C-based modules. We can write wrappers. There's a C Go library also which we can use to call C based functions inside Go. So I think that can fill the gap, because there are some Go libraries missing for Intel GPUs. But I see that there are libraries in C++, so we can use the CGO module, like just import C inside Golang, and we can use those functions for fetching the information.
True. Yeah.
Okay. Thanks.
Yeah. Like there's also the library that you suggested last time. So yeah.
Yeah. That
to look
one is,
into.
I think that is a direct Go library, so we can use that directly. But for Intel, I was looking, because I got an Intel Arc GPU recently, and I was trying to play around it and see how I can get the information in using Go and C++. So currently I'm doing some debugging in C++ so that I can call that inside Golang. So yeah, currently.
Awesome.
See. Yeah.
Okay.
Thanks.
Thank you, Avi.
Thank you, Darin. Thank you, Kabir, and everyone. See you on daily.